All right, guys, so if we look at these here, we have 4x minus 5 times x minus 3 and 4x minus 4 times x minus 4. Now, if we were to multiply these together, how would we go about doing that? We would do what? 4x times x. And 4x times x is 4x squared. Then we would do 4x times negative 3. And 4x times negative 3 would be negative what? X, because 4 times negative 3 would be negative 12, and x times, well, it's just x. We have that there. Then we do what next? 5 times x. Well, negative 5 times x is negative 5x. And negative 5 times negative 3 would be plus 15, because this would be our distributive property. We're distributing throughout both terms. And last but not least, we do need to combine like terms, which would be our negative 12x and negative 5, which would give us 12x squared minus 17x plus 15. And y'all remember doing this in Algebra 1, multiplying these through, doing it one step at a time. Some call this FOIL, first, outer, inner, last. But we've done this before. Now, what we're going to be looking at today, tomorrow, and Friday is not going this direction, but going the other way, starting out with our quadratic and defactoring, or factoring it back out into our two sets of parentheses. Now, we're not going to worry about that there. So previously, you factored the polynomial of the form ax squared plus bx plus c, where a is equal to 1. To factor the polynomial of the form ax squared plus bx plus c, where a is different than 1, first look at the GCF and then the terms and factor if possible. Well, the first main step in factoring is going to be to find the greatest common factor. The first main step in finding or factoring is the greatest common factor and seeing if there is one. Now, negative 1 can still be considered a greatest common factor, and we'll look at that later on. Now, the second step that we're going to use is to write two sets of parentheses. To write two sets of parentheses. Now, step 3 is going to be to find the sign. And it's going to be the sign inside the parentheses. And this will make sense, especially when we start working through each of these steps. Now, when we find the sign, 1, if the third term is positive, then the signs are the same and they match the sign of the middle term. If the third term is negative, then the signs are opposite. brings us to step number 4. Does anybody know what step number 4 is? Find the factors of the first and third term. And then last but not least, step number 5 is plug and check. Plug and check. So I do have those already written out on the board, not the smart board, but the whiteboard. I do have them written out for you also. When we are solving these, we do have them written there too. Now, these are the main steps that I find useful for factoring quadratics, or these 3-term polynomials, where the biggest degree is squared. So let's actually start using this. So we have 5x squared plus 15x plus 10. Is there a greatest common factor between 5x squared, 15x, and 10? Is there a number that will go into all 3? Is there a number that divides into all 3, or a number and a variable? 5. 5, 15, and 10 are all divisible by 5. So we can factor it out. And when we factor it out, what we're doing is really dividing each one of these terms by whatever that is. So we're really dividing each one by 5 to pull it out front. Well, 5x squared divided by 5 is like squared, because 5 divided by 5 is 1. 15x divided by 5 is going to be plus 3x plus 10 divided by 5 is 2. Now at this point here, we're not really focused on that anymore, because when we go to the checking step, the last step, we're not looking back at this here because we already factored the 5 out. Now we're mainly focused on factoring this here. So our first step was to factor out the 5 to make it a little bit easier to work with. Did we finish step number 1? Yeah, there's no other greatest common factors between x squared, 3x, and 2. Do all of them have an x? Well, we have x squared and x, but does the 2 have an x? No, so I can't factor it out. We'll have 1, 3, and 2. Well, 3 and 2 are both prime numbers. 1's not prime. But there's not any other numbers I can pull out, correct? So is step 1 done? Well, yeah. What's step number 2? 2 sets of parentheses with 3 spaces. So 5, 1, 2, 3. There's 1 set. Parentheses, 1, 2, 3. 2 sets. Because when we multiplied at the beginning, we did have 2 sets of parentheses. And we had, I think it was like 4x plus 1, or we had a number, a sign, and a number. And then we had a number, sign, and number. We had 3 things in each one, including the sign, yes? And that's what we have. That's what we're leaving space for. Okay. We finished with step 2. Well, yes, aren't we? What's step number 3? Define the... So if the third term is positive, the signs are the same, and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, there is some ingenuity in this. I'm going to look back at this here. Where did we get the 15 from? Negative 5 times negative 3, yes? Because a negative times a negative is a... What's the other way I can multiply 2 numbers and it turn out to be positive? As if they are both what? Positive, because a positive times a positive is a positive. A negative times a negative is a positive. Now, when they were both negative, our middle terms, the negative 12x and negative 5, which came from multiplying the middles together, were both negative, yes? And a negative plus a negative is a negative, because if I add two negatives together, we get a negative. Well, wait a minute. So if the middle last term is positive, well, it means the signs either were both negative or both positive, yes? And when I add two negatives or two positives, well, two negatives would give me a negative. Two positives would give me a positive. So if that last term, when multiplied out, is positive, like it is here, it means that the third terms, when multiplied together, they were either both negative or both positive, because that's the only way two numbers can be multiplied together and give me a positive. So when we look at this here, if the third term's positive, which it is, yes? Then the signs are the same and they match the sign of the middle term. Well, what's the sign of the middle term? Positive, yes? So inside here, we would have positive and positive, because that's the only way this will work out. Questions on this here? Any questions on this so far? Are we finished with step number 3? Step number 4, find the factors of the first and third term. Our first term is x squared and our third term is 2. So factors, what multiplies together to give me that? So what are two things that multiply together to give me x squared? Yeah, what is it? X and x. Are there any others? Well, 1 and x squared, but we won't use that because it doesn't actually work for this here. We would have x and x. That's the only real factors of x squared. Now, what are the factors of 2? X squared would be x and x. Factors of 2, what multiply together to give me 2? 1 and 2. And we'll just plug them in. Is the order in which we plug these really doesn't matter, because what we're going to do at the end is we're going to check it. We're going to multiply it back out. Like we did at the start. Now what is x times x? X squared, yes? X times x is x squared? Wait, where did I get the two x's? Where did we get this x and this x here? Well, they are the factors of what? X squared, yes? So if I multiply them back together, I should get back to x squared. How about 1 and 2? What are the factors of 2, yes? So they should multiply back together to give me the third term, yes? So the only one we're really focused on is the middle term. So that would be our x times 2, which is positive 2x. And then our 1 times x is, and what is 2x plus x? Is that what our middle term was before we factor? Well, yes. So middle term matches up, doesn't it? Because when I multiply this back together, we do get 3x. Now, we could have done it for all the way through. X times x would be x squared. 1 times 2. Okay, that does give me the polynomial I had before I factored. So our answer is that there. That's all we're doing. Because we're just factoring this back into 2 sets of parentheses. Now, we will need the greatest common factor included in the answer because that is part of the polynomial. Questions on this here? Let's look at another one. 4x squared plus 32x plus 60. 4x squared plus 32x plus 60. What is the first main thing we should look for? Greatest common factor. We need to look for the greatest common factor. Is there a number that will divide into all three terms? 4. Because 4x squared divided by 4 would be x squared. 4 divided by 4 is 1. Now 32x divided by 4 would be plus, because 32 divided by 4 is 8. And lastly, 60 divided by 4, 15. So there was a greatest common factor of 4. If there's a greatest common factor, we need to factor it out. So that's step number 1 done. Step number 2 is write 2 sets of parentheses with 3 spaces. Okay, that's done. Step 3 is to find the sign. If the third term is positive, then the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. So what's the sign of our third term? Positive, yes? So the signs are the same and they match the sign of the middle term. What's the sign of the middle term? Positive. So we would have plus and plus. They'd both be positive. Okay. Any questions on this so far? Now we're on to step 4, find the factors of the first and third term. So our first term is x squared. Well, what's the factors of x squared? X and? Are there any others? No, if there's only one set of factors, we will just go on and plug it in. Just go on and plug it in. Because if there's only one set of factors, we plug it in. Now, do we need to plug it in the exact proper order at this point? What's our last step? Plug and check, yes? So even if I do not put it in the right order at this point, we're going to check it, and if it's wrong, we can fix it. So having it in the exact right order at this point is not a big deal. Now we need to look at the factors of 15. What are the factors of 15? 1 and 15 and 3 and 5. Which one do we want to try first? 3 and 5? Okay, so I'll just plug them in. Because I could have done 5 and 3 or 3 and 5. I'm just going to plug them in and then we can check it. Because the factors of 15 are 1 and 15 or 3 and 5. Any questions on this here? Any questions about anything we've done so far or why we picked what we picked? Now the last thing we need to do is to check it. Now we could do x times x, wait, but that'll still give me x squared, yes? Because x and x are the factors of x squared. They should multiply back together to give me x squared. What about 3 times 15? Or 3 times 5 would give me back to 15. The reason I got 3 and 5 is because they are the factors of 15. They multiply together to give me 15. So we're looking at the middle term. X times 5 is 5x. 3 times x is plus 3x. And 5x plus 3x is 8x. Is that the middle term that we want? Well, yeah, that's the middle term that we had before we factored it. So that is correct. So this is the correct factorization of our 4 times x squared plus 8x plus 15, or it's the complete factorization of our 4x squared plus 32x plus 60. And we get this here. Any other questions on this here? All right, because again, we're going to be looking at a lot of these today. So let's look at the next.
Where'd you get the 3 and the 5?
So, other direction. 3 and 5, so we're looking for the factors of 15. So two numbers that multiply together to give me. So 1 times 15 is a set of factors. The other factors are, because 3 times 5 is 15. So that's where we get the 3 and 5 from. Yeah, I could have picked 1 and 15 or 3 and 5. Now, we just picked as a group 3 and 5 and just plugged it in and checked it. It turned out that it did work, so that's the answer. Now, if we'd have plugged it in and it gave us something other than the middle term of 8x, then we would have had to try something different. Yes?
You were always told that all factors should add to the middle number and multiply it.
Yeah, and that does work. That works well. The only time it kind of goes a little different from that is if the numbers in front of x aren't 1. Because if it's 2x, if this was, say, 2x here, because then our middle term would be 13 in this setup, it would work because 5 and 3 would still give us 8, but because of the 2, it throws a little bit off. But that is a great way to do it. Now, a lot, if we go back a few more steps, a lot of what we'll see here, and utilize that, is there's a lot of patterns that do come up, but the more that we do this, the more patterns that we will see, or the more patterns that you'll start noticing and picking up on, and ask. Because that works on a lot of these here. Because again, as you were saying, they add together to give us the middle term, so 3 plus 5 would give us 8. That would work. So let's look at this one here and see if we can see the same thing. Great questions. So we're going to start off with what? Thank you. We're going to start off with greatest common factor. Is there a greatest common factor between these three terms? Is there a greatest common factor between 4x squared, 13x, and 3? Well, no. 13 and 3 are both prime numbers, so they won't have any other factors between one and themselves. So here, unfortunately, we don't have a greatest common factor. So we can move on to step number 2, which is write 2 sets of parentheses with 3 spaces. Find the sign. So we look at the third term. Well, here the third term is positive, so the signs are the same and they match the sign of the middle term. What's our middle term? Positive, so the signs for both of these will both be positive. So that takes care of steps 1, 2, and 3. Our fourth step is to find the factors of the first and third term. So we have 4x squared and 3x, yes? Well, the x part, the only factors of x squared are x and we put it in the first place because 4x squared comes first. Now, what are the factors of 4? Well, 1 and 4 and 2 and 2. We do have 2 different sets. Which one do we want to try first? 1 and 4 or 2 and 2? 2 and 2. So we'll put 2x and 2x. Now, what are the factors of 3? 1 and 3, because we're always going to have 1 times the number. And since 3 is prime, that's it. Because 1 times 3 is it. Those are the only 2 factors of 3. Now, because there's only 1 set of factors, we can just go on and throw it, and we'll have to use it. Because the only factors of 3, 2 numbers that multiply together to give me 3, is 1 times 3. Now, making sure that we have that set up in the correct way is not hugely important because, again, our last step is to check. Well, 2x times 2x, well, 2 times 2 is 4, x times x gives me x squared. Well, yes, we expected that because that's how we got 2x and 2x. 1 times 3 will give me 3, because how did we find 1 and 3? Well, they are the two numbers that multiply together to give me 3. So let's check the other one. 2x times 3 is 6x. 1 times 2x is plus, and 6x plus 2x is, and that's our middle term, so we have it correct, yes? What is the middle term? 13x, yes? And we got what? 8x. So is this the correct setup? No, okay. So could we switch the 2x and 2x? We can do that, yes, but would it change anything? No, because we're switching the 2 with the 2, so that doesn't change anything. Could I switch the 1 and 3? Well, it wouldn't change anything because it's still being multiplied by 2x, yes? We'll need to switch out the 2 and 2 because neither of those is working. And replace it with a 1x and 4x. And then we can check it again. Well, our first term's x times 4x is still 4x squared, yes? Because, I mean, that's still where we got the 4 and 1. 1 and 3 is still going to be 3x. Now, x times 3 is 3x. 1 times 4x is plus 4x, which gives me 7x. Is that what we wanted? No, we need it to be what? 13x. Okay, so what can we switch now? The 1 and 4x? So we can say 4x and 1x. Let's check it one more time. Well, 4x times 3 is, and 1 times x is, plus x. So 12x plus x is that what we wanted? So that's the answer. So a lot of this here is just plug and check, plug and check. Now, the more that we do this and the more that y'all work these, the better you'll be able to see them. To see what is going to probably be the better setup for this to get to the correct answer. So doing more of these is helpful. Any questions on this here before we look at the next one? Let's look at this one here. So here we have 3x squared minus 7x plus 2. 3x squared minus 7x plus 2. Is there a greatest common factor? Well, no. So we can move on to step 2, which is 2 sets of parentheses with 3 spaces. 2 sets of parentheses with 3 spaces. And this kind of gives us our overall setup of how we're going to do this here. Now, that finishes step 1 and 2. Step 3 is to find the sign. So if we're finding the sign, well, we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If it's negative, the signs are opposite. Well, here our third term is positive. So the signs are the same and they match the sign of the middle term, which is negative. So our two signs would be negative and negative. Any questions on this here so far? What we do next, the factors of the first and third term. Well, the factors of our first term, so we're looking for the factors of 3x squared. Well, we know x squared is going to be x and x. The factors of 3 are 1 and 3, because the only thing that multiply together to be 3 is 1 and 3. And we can just throw it in because, again, what do we do at the end is we check it. We plug and check. So even if we get the setup wrong at this point, we'll eventually check it to make sure. Now, what are the factors of 2? 1 and 2. Which one do we want to use first? It doesn't matter, so pick one for me. 1 and 2. And last but not least, we already plugged, so we're going to check. 3x times negative 2 is negative 6x. Negative 1 times x is negative x. Negative 6x minus x is negative 7x. Is that what we wanted? All right, we're done. Huh? Or only find negative 7? Well, the reason that we do this here is because I think probably Siloam told you to factor or multiply all the way through. Well, it is. That works. That works just fine. But I find it a little bit tedious or unnecessary because I can still do 3x times x. And 3x times x is 3x squared. And negative 1 times negative 2, negative times negative is a positive, and 1 times 2 is 2. Well, where did I get the 3x and x from? Because they're the factors of 3x squared. They're the two things that multiply together to give me 3x squared, yes? So if I'm checking it and I do 3x times x, well, I have to get back to 3x squared, yes? Because those will be the exact same. I got 1 and 2 from the factors of 2, so they should multiply back together to give me 2. The only thing that's really changing is, let's get another funny color. This one here and this one here. Because as we saw in the last one, when we changed those numbers around, the middle term changed depending on what the first set of terms was and the second set. Because what we put here and here, and here and here, when multiplied together, changed the middle term. But the first and last terms are still the same. Does that make sense? Yeah, and there's nothing wrong with doing that. Because if you want to go on and multiply the whole thing out, do it. You'll get the same thing. It won't change anything. I don't include that or do that because, well, because I know that 3x and x will always multiply together to give me 3x squared. Since they're the factors of 3x squared, I don't do it. Since I know that 1 and 2, negative 1 and 2 gave me positive 2, because that's where I got them from, I just leave both of those steps out. Does that make a little more sense? I mean, it works just fine because from a pure mathematical standpoint, when we check it, that's what we're supposed to do. But if it's already set up that way, I don't bother with it. But you can do that. That's perfectly fine. And I think Siloam teaches the cross method. Yeah, so the x and putting terms. Yeah. Because I will say this, the steps that we're doing here, I have not found it in any textbook that they teach it exactly this way here. This is from my Algebra 2 teacher, and looking at it, this is, I feel, the most logical way to set it up with the least amount of steps. Because when we look at this here, I mean, greatest common factor is taught. That's the first thing we should be really looking for. Now, is there a greatest common factor between 2x squared, 7x, and 6? Well, 2 and 6, yes, but not with 7. So we don't have a greatest common factor of anything. Now, with any quadratic, we are going to end up with two sets of parentheses, two things being multiplied together. One of them will have, they'll both have a sign with it. Factors of the first term, factors of the second. Now, the nice thing about step 3 is it removes a lot of the steps with signs. Because what they'll do at this point is not talk about the signs, but the factors of the first and third term. Because we'll talk about the fact that 6x could be 1 and 6, or negative 1 and negative 6. or 2 and 3, or negative 2 and 3, and talk about it being both positive and both negative, and looking at all those different possible factors. But because we know that two numbers that multiply together to give me positive have to be either both negative or both positive, and when added together, it'll be the same, we're really saying that since the 6 is positive, the signs have to be the same. Because a negative times a negative is a positive. A positive times a positive is a positive. So that's what this positive 6 is telling me. Now, since I combine, when we do the distributive, we end up combining the first and third term together to get the middle when we do that distribute. So this sign tells me what it is. Since it's positive, it means these are both positive. Because when I do the first times last and the middle two and add those together, those signs are going to match up. So they would both be positive. Now we need to find the factors of the first and third terms. Well, the factors of 2x squared, 1 and 2, so we can say 1 and then x squared would be x and x. Now we can say 1x or just x, both of those are fine. Now what are the factors of 6? Well, 1 and 6, 2 and 3. What do we want to try first? 2 and 3. You don't like that? Well, we can go on and check it and see. 1x times 3 is 3x. 2 times 2x is plus. 3x plus 4x is that what we wanted? Yeah, so we're done. Now I'm going to change this. Well, we know it won't be right because we already found the correct answer, yes? So you don't have to write any of this down. Say I did 3 and 2. Well, we already know this won't work because the correct answer is going the other direction, yes? If I have this set up, well, wait a minute. Is there a greatest common factor here between 2x and 2? Because if I put those together, we have a greatest common factor of 2, yes? Is there a greatest common factor to begin with between 2, 7, and 6? No, so should there be one in either one of the parentheses? No, because if there is one, like this 2 here, then I should be able to factor it out, put it out front. And we'd have x plus 3, and this here would be x plus 1. That's kind of helpful. Because since that tells me, well, if it factored out here, well, wait a minute. There is no greatest common factor here. So it means there cannot be a greatest common factor in either one of these here. So wait a minute. So we know that 2 can't go here. What else couldn't go here? The 6. There's 4 different arrangements we could have with those 2 numbers. Wait a minute. So this setup and having 6 there, that's 2 of them, isn't it? So we've taken it from 4 to 2. We've taken 2 out. So that's kind of nice to know. But if you don't remember that, just checking it will tell us, no, it doesn't work. Let's look at this here. Any questions on this so far? Is there a greatest common factor between these 3 terms? Well, no. So we'll have 2 sets of parentheses with 3 spaces. Now we look at the sign of the constant term or the third term, and it is positive, so our signs are the same, and they match the sign of the middle term, which is negative. So we would have negative and negative, because the signs are the same, and they're going to match the sign of the middle term. Now that takes us to step 4, looking at the factors of the first and third term. So, well, the x squared and 4x squared would just be x and x. Now the factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. And the factors of 3 are 1 and 3. Well, since we only have 1, we can go on and plug it in, and then we can check it. Now, 2x times 2x would give us 4x squared. Now, 2x times negative 3 would be negative 6x. Negative 1 times 2x would be negative x, which is negative 7x. Negative 7. What am I doing? Negative 1 times 2x would be negative 2x, which is our negative 8x. So is this the correct setup? No. I was really hoping it would be negative x, because then that would work. So what can we do? Do we want to change 3 and 1 or 2 and 2? 1 and 4, yes. 1x and 4x. So x and 4x. And we can check it again. X times negative 3x is negative 3x. Negative 1 times 4x is negative 4x. And negative 3x minus 4x is negative 7x. And that's it. Any questions on this here? Any questions over anything we've done so far? You feel pretty good with this here? Okay. I know that we do have a lot more examples. Mm-hmm. Yep. So the signs will be opposite. I want to go on and give you this here. We will cover those tomorrow, first thing tomorrow, okay? Because that is the bell. But we will cover those first things tomorrow. And we'll be dealing with these factors throughout the week.